Xin chào Vietnam. Hi. Before we start, I have a question. So how we deploy our images in Kubernetes? What is the general process which we follow to deploy our images in Kubernetes? Okay, so we start from the developer. When developer push the code, it goes to your CI/CD. Image is getting built, and it goes to Argo CD. So Argo CD does the automatic reconciliations. Any image getting updated, getting new code, it will be reconciled, and it will put to the productions. So that's how it looks all over. And each telemetry data will be recorded, and the relevant things will be pushed on the webhooks or Slack. So that's how it looks at the plain vanilla level when we deploy any images in the Kubernetes. Okay, so this seems all good, right? Is there any problem which you feel that? But the problem is that can we trust whatever is running on the Kubernetes? We say that, okay, we have follow all the security guidelines to make sure that builds are secure. But what about the runtime is secure? So that's what we're going to look at today. Okay, because when I say but, there are few concerns comes at each layer. So how when the code getting built, how the code getting signed, and how when the code getting deployment. There are various issues can be found out while building and deploying the images. Okay, yeah, my name is Jitendra Singh. I work at Microsoft. So today I will be talking about how we can achieve zero trust when we deploy the images in the Kubernetes, and how we can also trust that it's getting securely running on the Kubernetes. Yeah, they're my LinkedIn handles and QR code I have put it. You can check it out. Okay, so I will be running through agenda, talking about basic GitOps foundations and what are the gaps exist, how we can close those gaps, okay, and what are the software supply chain tools exist. With the help of that, along with that, confidential containers, which provide the runtime isolations. I will be talking about in detail in the next slides, and then we'll talk about a few of the takeaways which should be followed. Okay, so first we'll go look at what are the GitOps foundations. So at the plain level, it looks like that GitOps is having a declarative infrastructure. It follows Git as a source of truth. Whatever there is Git, it will be deployed the same. Anything which come as a new code and only drift occurs in code, it will do the automatic reconciliations, and it will deploy the cluster. So this looks all fine, right? But there are few issues exist. Running deployment is autonomously doesn't mean that it's running securely, okay? Also, there are issues with signed malware. You have trust that, okay, I signed my coded, but there will be no problem. But malware also can come as a signed image and can deploy to the Kubernetes cluster. Other than that, there are runtime attacks and CI compromise also exist. Okay, now let's talk about how we're gonna fix them, okay? So we cannot fix at one level. We need to think about at each layer, okay, how we can achieve and fix the security gaps. So GitOps has to make sure that we are having enough policies to control that, right? And software signing, which has to provide the software provenance. Who built it, what was built, who signed it, all the provenance record has to be there. And then when we are running it, right, after deployment, when we are running it, how the images are running securely. We would be having some kind of telemetry. It says that, okay, you are running securely. There have been no attack on the images in the runtime. So combining all that, okay, we will say that we can achieve the complete runtime trust on the Kubernetes images, which will be solve the problem. Okay, we can go to the next slide, please. Okay, so as I was talking about, the two gaps exist. First is the pre-deployment phases, and the second is the post-deployment phases. So how now we look at how we can solve the problem of pre-deployment phases. Okay, so in the other session, somebody was talking about Sigstore, which solved the problem of supply chain security. So yes, I will be talking about the same. So Sigstore provides the software signing and provenance. It has some tools, Recur and Fulcio, Cosign, which make sure that keyless signing. And also it creates a record, who signed it, okay, what was the signature digest. If anything try to modify, the digest will not match. So it makes sure that, okay, whenever you're going to deploy the images, the signing has to match. Okay, so this is all about the pre-deployment phases. Now your images is ready to deploy. You're going to Kubernetes cluster, okay, how we gonna achieve the security at that? Okay, so many of us aware of two kind of data encryption techniques. One is the data at rest, one is the data in transit. There is another level of encryption which talks about data in use. what happened when you have encrypted data, okay, data has reached to the destination, and now you are processing it, right? You have decrypted it and it's in memory. That data can be leaked at any time. So we will be talking about how we can secure that. So there is a concept called confidential computing, which comes from hardware level isolations, and using that, the confidential containers evolve and use that technology. So we will be using that for our runtime isolations. Okay, so let's try to compare first the normal container, which we already have it, and what is the confidential containers. So in normal container, it's shared the same host kernel. If anything goes wrong with the host kernel, if it gets compromised, the same attacks could also affect the other containers, right? On the other hand, sorry, can we go to the previous slide, please? Yeah, previous. Back. Yeah, hold on. So on the other hand, confidential containers use a confidential runtime environment which comes from hardware isolations, which is technically called TEE, Trusted Execution Environment, which is running on the separate hardware. So we will be using a runtime class kata container. Kata container is provide hardware isolation, but it cannot work on own. It needs real hardware to run on that. So that's where we are using here Azure Confidential VM, which is Microsoft Azure Confidential VM, but it has the hardware capability from AMD or Intel, TEE, which I was talking about. We will be running our workload on that. So the advantage we will be having here, it runs on a separate micro VM. So if you look at here, each container will be having a micro VM. All the data, whatever we are processing, it will be encrypted. Not even the root, not even the admin can access that. And that will be, if anything get compromised, right? So other container will not be having any effect. Okay, now we have understood that how we can secure the pre-deployment phase and how we can do the post-deployment phase techniques. Now let's combine and understand it. Okay, so it starts from the very first slide which I was talking about. Everything comes from Git. The image is getting built. Sigstore will provide you a provenance, who built it, image, what the digest, everything. And then image will push to registry along with the digest and certificates. Now, here comes Argo CD. So Argo CD is just like, it replaces the images. It doesn't have any intelligence, okay? So it has to be rely on some policies. Where does the Kyverno comes in? Kyverno follows the policies. If anything goes change, anything doesn't match, right? Like few policies you can set up, right? If a certificate getting tampered, right? Those things will be achieved on the Argo CD along with that. If at all, any policies get rejected, the deployment will not happen. So we have this stage, which is called pre-deployment phase. The next, if policy is allowed, now we're gonna deploy the image in the cluster. That's where Kubernetes API requests to the kata runtime container, and the confidential container will be spin up on the confidential worker node, okay, which is backed by TEE, which I was talking about in the previous slides. And when your trust will be done, then only the key will be released. You having a databases key, you having any API keys, that will be released only when the addition done. Next slide, please. Okay, now I'll talk about what are the key takeaways we have it here. So previous to that, we are just assuming, okay, we are running our workload securely, we are running our data securely, but now we can measure it. What exactly happening behind it, how we are achieving that. I'll just run a small demo of that. Okay, so in demo, I will be talking about attacks where we have a plain vanilla image running, which is leaking your secrets on the base 64, because that can be decrypted anytime. And the other two, because I've been having two namespaces, which is running in secure and others in non-secure mode. The secure one using confidential container, and the which is also having the Sigstore policies. And the third one, we will be showing that how it will be achieving the runtime trust. Okay, so I will be having two node pool. One is actually the confidential containers backed by Azure Confidential VM, and other are normal pools. They don't have any security enabled it, okay? So if you see Azure Linux, which is having the confidential VM, AKS pool of the kata containers, I have set up the Kyverno policies, and I have the attestation agents, which is running and verifying the hardware attestation, then only to release a key. Now, after this, I will be setting up the KBS. So KBS is key broker service, which will be releasing key only after attestation. Now, I'm spinning up the Argo CD. Once Argo CD deployed, it's try to deploy the application on the back insecure. So here's the application running, which is leaking the keys on the base 64. Anybody have access to that, right? Once it will be mounted to /etc, anybody can try to access and decrypt that. So that's where it's leaking those secrets. The other side of it, which we look at in the back, secure API. That's where we'll be having Sigstore policies, and it will try to detect those secrets that are getting leaked, and it will block there only using Kyverno. So here, if you see, right, those warnings are coming. Now here, we see that with the help of Kyverno, those policies getting detected, and the deployment will not happen. It will get rejected. Can you forward a little bit? Yeah, so can you just forward a little bit?
Stop. Run.
Little bit forward. Yeah, okay. So here we have two policies which detect that the secrets are getting leaked, and that's where the deployment will not happen. This is, we are talking about pre-deployment phases. The last demo which we have, scene 3, where we have Kyverno also finding the policy triggered. Also, it making sure that those deployment which is achieved for the Kata container should deploy there only. And none of the secrets, none of the data which have been deployed there cannot be leaked, because not even root, not even admin can access that. Even if try to access that, right, it will get the encrypted data. Can we just forward a little bit more? Yeah. So this policy I was talking about. Can we just let it forward a little bit more? I think we are on the end. Yeah, so this is the real environment where we're talking about. It has the confidential containers and the Sigstore both have been running. And it is making sure that whenever we're getting requests from the Kubernetes API for Kata runtime, then only it will deploy. And then only the key will be released. Bank API secure. So if anybody try to deploy any images here in this namespace, it will not accept it, it will reject in the both phases. Yeah, Kata CC runtime is there. So none of the secrets will be released, and it will be completely secure. Any questions so far? You can go to the next slide, I think. Yeah, so these are the few matrices which I was talking about, which will be helpful for the security auditors, which talks about that whether your security, what we haven't built it, can be measured it. It does not be assumed. So those talk about how many images have been tampered, if at all we have received any attack, how many images we have deployed successfully, securely. Those are the matrices. Yeah, we can go next slide, please. Yeah, any question? Yep.
Thanks for your presentation. I have a question about the cost of implement the deployment, the cost of operation, and does this impact the performance of the workload?
Yes, definitely. So this will impact the performance, but actually comes where we are dealing with a very security environment, right? We're dealing with sensitive workloads. That's where we deal with trade-offs of security and performance. So that's where it comes in. So this is very helpful when the security, when the industry like governments, healthcare, banks, those enterprises are really, the core customer for these kind of technologies.
Thank you.
Yep, thank you.